Hello there, my name is Mr. Roche, and welcome to Mr. Roche's Flip Class Math 10. No frills, no thrills, low budget, low tech videos. The other day I met a fellow named Tom Hanks, and he introduced me to his buddy Wilson. Now, Wilson is really happy today because he's going to learn all about polynomials from me. And while I teach him, listen along, maybe you'll learn something as well. Wilson, I'm going to sit you over there. Okay. So, Wilson, here's what we're going to learn about today. First of all, we're going to find out some vocabulary and terminology that you're going to need for understanding this unit. Second, we're going to learn about something called degree. Then you're going to see what algebra tiles are and how they work. And we're going to find out about like and unlike terms. And finally, we're going to learn to add and subtract polynomials. By the way, all these things were learned in grade 9 math as part of their polynomials unit, so this should be reviewed. Our first topic is the vocabulary and terminology. First of all, the word polynomial itself means a many-termed expression, poly meaning many. A term itself consists of a numerical coefficient, which is a number part. Sometimes we abbreviate that to just coefficient. And often a variable coefficient, or a variable chunk. It would be all the parts with variables and their exponents. Terms are separated by plus and minus signs. Here's an example of one term. You'll notice it has a numerical coefficient, -5. The variable coefficient is that chunk, x squared y. The actual variables are just the letters which are x and y. Note, although any term or collection of terms can be called an algebraic expression, not all algebraic expressions are polynomials. So a polynomial is one or more terms, as is an expression. However, all exponents of the variables must be positive integers in the numerator if it is actually a polynomial. Let me repeat. All the exponents of the variables must be positive integers in the numerator. If that's not the case, it might be an expression, but not a polynomial. Got it, Wilson? That's good. Okay, here's some examples. Polynomials. -5x squared, that's a single term expression. Here's one with 2 terms, and here's one with 3 terms. In all cases, it meets the requirements of being a polynomial. On this side, we have non-polynomials. -5 over x. You'll notice the x is in the denominator. That disqualifies it from being a polynomial. Here we have 3x to the 1/2, 4x to the -3, and 6x to the 0.2. All of these exponents are non-positive integers, so they're all non-polynomials. Okay, at this time I'd like to introduce the word constant. That's a term that has no variable, or no variable coefficient. Okay? You'll notice in this particular 3-term expression that if we replace the x with a number, then this term could be, we could figure what that term is, we could evaluate it as we could this term, but this one would remain -9. If we change the values for x, this would change, but the -9 would remain constant. So hence the word constant. So in this particular expression, -9 is the constant. In this one, it would be +7. Okay, next, classifying polynomials. Depending on the number of terms that a polynomial has, we can give it a different classification or name. A monomial is a polynomial with 1 term, mono meaning 1. Binomial is a polynomial with 2 terms, and trinomial is a polynomial with, that's right, Wilson, 3 terms. Okay, here's some examples. This one has 1, 2, 3 terms. It's a trinomial. This one is a big term, but it does not have any plus or minus signs in it, so it's just one big product. It's one term, so therefore it's a monomial. And this one has 1, 2 terms for a binomial. Okay, next we're going to talk about degree. Okay, degree, the word degree is going to be used a lot in upper math, but right now it's just more important to kind of understand what it is, order of degree, and things like that. Okay, so first of all, degree of a term is equal to the sum of all the exponents of the variables, only of the variables. Okay, so for example, here's a term, 3x. There's an invisible 1 exponent over the x, so that has degree 1. This one, 5x to 3y, has 3 x's and 1 y. We expanded that out as a product, as a multiplication, and therefore it has degree 4. This has 1x, 1y, 1z for a degree of 3. This has degree 0 because there are no exponents. and this has degree 8. The degree of an entire expression is equal to the degree of its largest term. So here we have degree 2, degree 1, degree 0. So the degree of the entire expression is 2. Don't add up the degrees. Okay. The degree here is 3, 4, and 5. The degree of that second expression is 5. Okay, I'm going to introduce one other term at this point, and it's the leading coefficient. The leading coefficient is the coefficient of the largest degree term. So for example, in this trinomial here, the leading coefficient is 3. Got it, Wilson? Yeah, right on. Okay, next. Algebra tiles. Well, algebra tiles, let me see, here we go. These are algebra tiles. We'll work with those in class during some activities, but just so you know what the pieces mean, that is a 1, or a positive 1. If I had 5 of these, I'd have positive 5 or plus 5. This is a negative 1. If I had 3 of these, I'd have negative 3. And one of these and one of these together would make a 0. This tile is 1 wide, but it's not any particular number long, so we call it x long. So the tile itself has an area of x, and this is negative x. This tile is 1x long and 1x wide. It's a square. It's a square x, or x squared tile. And this is a negative x squared tile. Here I've drawn them symbolically to represent the actual tiles. So here's a review of what each one represents. This is how I represent a white tile, or the reverse side. In this example, negative 2x squareds are 2 white big squares, plus 3 x's are the 3 strips, plus 6 ones is the 6 little red ones. Okay, like terms. Like terms have identical variable coefficients. Okay? For example, 3x and 5x have the same variable coefficient, x and x, so those are regarded as like terms. As are negative ABC and positive 6ABC. It does not matter about the numerical coefficients, nor does it matter about the signs of those coefficients. It just matters about the variable coefficients. So those are like. These are also like. Notice they're both x to the 4. Had one been x to the 4 and one been x to the something else, they'd be not unlike. Sorry, they'd be unlike. More about unlike terms. They have different variable coefficients. For example, 3x and 7. Those are unlike terms. X and negative 2y, unlike terms because they have different variables. Here we have the same variable but different exponents, so they're still unlike. Note, we can only collect, which means add or subtract or simplify, like terms. So we could add these, that would be 8x's, we could subtract them, the negative 2x's, and so on. But we cannot add nor subtract any of those pairs. Hopefully that's clear. Finally, Wilson, I'm going to show you how to add and subtract polynomials. Okay, polynomials could be binomials, trinomials, could even be monomials. So we simply add all the like terms. For example, here's a trinomial plus another trinomial. Using algebra tiles, this trinomial looks like this. Oops, sorry, this one. And this trinomial looks like this. And if I put it all together, we would get this. 3x squareds plus x plus 5. Notice that these two negative x's cancel out 2 of those positive x's, so that's why we only have 1 left. Algebraically, it would look like this. We could add them horizontally or vertically, but again, we collect the like terms only. Okay, subtracting polynomials. Simply subtract each pair of like terms. Don't forget that each pair of like terms have to be subtracted. Or, some people refer to change the subtraction to adding the opposite. So for example, this trinomial minus this one is exactly the same as this same trinomial plus, instead of minus, the opposite of this one. So notice each sign has to change in that following polynomial. You got that, Wilson? Yeah, he's still smiling, so he's got it. Hopefully you have it too. If you don't, take note of what it is that you are still wondering about. If there's any words that you come across that you don't know the meaning of, write those words down and ask in class, and we'll take care of those. Okay, that's it for now. My next part, we'll start multiplying polynomials. Thank you. See you, Wilson.